All right, in this video, we're taking a look at Chapter 11, chi-square procedures on the Ti89. We're going to start with goodness of fit. For goodness of fit procedure, you would need to input your observed counts into a list in the stats app, usually list 1. And I'm using the M&M data from our first goodness of fit example from the Chapter 11 notes. And here I have inputted the very same observed counts from the notes. In the second list, we need to input expected counts. So to get those, you're taking the proportions from your null hypothesis and multiplying each one by the total sample size that you're dealing with, right? So if we had 46 M&Ms here in our sample, all those null hypothesis proportions, the entire distribution multiplied by 46. We're going to input all those results as well. Okay. And that's really all there is to it. Now we're ready to jump over to F6. Chi-squared goodness of fit is the one that we want. Tell the calculator which list is observed. I'll go to second minus find list 1. Tell the calculator which list is expected. Second minus list 2. Degrees of freedom would be number of categories minus 1. We had a total of 6 color categories, so 5 degrees of freedom seems good. Hit enter, and you get your chi-square statistic. You get the corresponding p-value. There's also a reference to something called comp list. We'll come back to that in a moment. I just want to jump over to the notes and just confirm we got the same answers as when we did this in class, and there it is, 11.37 for the chi-square, 0.044 for the p-value. So everything's looking good. Comp list, this is the component list, all the individual terms that are summed together to get the chi-square component. If I hit enter, you'll see that that comp list has been calculated for you, which is really, really nice, because if there's a follow-up question about which category differs the most from what was expected, you would just jump over here and find the biggest number. In this case, it seems to correspond to what was the, oops, I need to scroll up. See them all, yeah. It looks like the green category, okay. So I think that's about it for goodness of fit. I'm going to find a two-way table example next. Let's jump down to 11.2, and this one looks as good as any. The Zoloft St. John's wort placebo example. Now this was homogeneity, but as far as the calculator is concerned, there really is no distinction in the math behind homogeneity and test for association. So while your write-up is going to differ, the technique I'm about to show you works for both homogeneity and also association. And this is also a bit more complicated than goodness of fit. In fact, it's going to require us to involve another app on the calculator entirely. So I'm going to go, oh shoot, where even is it? Flash app, that's not what I want. Looking for a data matrix editor, and oh, there it is. My menu is possibly a little different than what you use on your end. It should show up in your home screen next to your stats app somewhere. But I want data matrix editor. And once I highlight this, I can either hit enter or arrow to the right. It says current, open, or new. I'm actually curious if I have anything currently saved. I'm going to go with current. And okay, so there is something saved. In fact, it's the numbers from this very same problem already there. Oh, you know what though? I need to know what I called this thing. So give me just a second. I'm gonna go to open instead. And this is what I would want you guys to do, especially if it's your first time through. You don't have a current matrix necessarily open. So if you go to open, This is where you would go if you already have something saved. This is really important. Where it says type data, you always need to change that to matrix. You'll never use the type of data. If you go with that, you're going to get errors in your stats app. And as soon as I switch to matrix type, I see actually this is the matrix I've been working with. It's called OBS, as in observed counts. I made it myself. That's what I'm going to use. I stored it in the main folder. I would just keep everything in main. Right now, it's the only matrix that I have in there, so it's the only one that you see pop up as a choice. And when I open it, there are those numbers again. Now, for you guys, you don't already have a matrix called OBS, so let me show you how you could create one. When y'all open up Data Matrix Editor, you could go to New to create a new one. And again, the type has to be matrix. Folder, you probably want to leave it alone. Variable, you do have to give this thing a name. You can give it whatever name you want. I always use OBS for observed. Then you can set the dimensions to a 3x3 to match this problem. And then when you hit enter, you'll have your OBS. Now, again, mine already exists, so I don't want to make a new one. I need to go back in and choose open matrix type. There it is. And now we're in. Now, you probably want to avoid saving a bunch of matrices in your calculator and then running out of things to name them, because you have different ones for every problem. If you're like me, maybe you want to just have a single matrix of observed counts to use for chi-square problems. Now, having said that, the dimensions of the matrix would have to change from one problem to the next. So let me show you how you could change dimensions if necessary. If I go to F1, the tools menu, and scroll down far enough. Oh, just kidding. Not F1, where is it? Oh, here it is, F6. Sorry about that. F6 utility, resize matrix. Allows you to change the row and column dimensions. Again, I'm going to keep it as a 3x3 for now. Why did I think it was F1? I don't remember why. Okay, doesn't matter. So yeah, you can go from cell to cell, inputting values and hitting enter as you go. Again, I don't need to change anything in mine, so you can just overwrite things here. I'll change this 27 to a 34. Let's change it back to a 27, hit enter. So once everything's in here, we just got to keep a mental note. Our observed counts are stored in a matrix called OBS. And once it's all stored, we're going to make our way back to the stats app. And now we are ready to go to F6 chi-square two-way. Again, the two-way calculation works for both homogeneity problems and association problems. Let's enter in. First thing it wants to know is, hey, where are your observed counts stored? So you could either type in OBS, or you could, again, go to second minus and hunt around in here. There's my OBS as a matrix. I'm going to click and store it. The calculator, upon running this procedure, is going to make two additional matrices for us to look at. It's going to give a matrix of expected counts, which is going to be really helpful because we're going to want to put those all in our write-up. And then it's going to give the component matrix for all the different pieces that add up to form the chi-square. So that's kind of nice. Let's show you how to access those. First, we hit enter. Chi-square is 0.871, p-value of 0.068, shows you the degrees of freedom. I'm just going to confirm again with our work from this problem when we did in class. There's that chi-square of 8.7, p-value about 0.068, so it is working out. Now, once you run all of that, you are going to need to go back and fill in some of the work. So it's funny, you'll probably get your final answers before you actually finish the expected count table from your conditions. So where do I get all these numbers? Let's take a look. I'm going to go back to the data matrix editor and go to open. type matrix, but this time I'm going to change the folder to StatVars because any matrix that is created by the stats app is going to show up in this folder, and there are the two options, compmat and xmat. I don't even know what this third one is. That must be something else that I stored some other time. But xmat is expected counts. If I choose this one, hit enter, it'll take me in there. These are exactly the numbers that match up with the counts on the solutions here. In fact, this is where I got the numbers for the solutions, is by pulling them from my calculator. So yeah, that's kind of cool to have. If I hit F1, I can open something else, matrix type, StatVars folder. This time I'm going to open up the comp mat, which is all the various components. Here in this problem, we failed to reject the null, but if we had rejected the null, we would be really curious which of these values was the biggest. It looks like the one from the middlemost cell, that would be Zoloft partial response group. Seems to have the biggest chi-square component, but we're not that interested in the component matrix if we fail to reject the null. Okay. I think that is about it. I'm going to jump over to my stats app one more time just to be sure I didn't forget anything. F6. Yeah, I think we're good. All right. So if you have any questions, let me know. Email, come to academic support, and thanks for watching.